Hello students, welcome to my lecture series on reinforced concrete structure. In today's lecture, I am going to discuss about mixed proportions. The outcomes of today's lectures are, after completion of this lecture, a student will be able to know what are the objective of concrete mix and he has to distinguish between nominal mix and design mix and what are the methods are available for design mix and step-by-step procedure of IS code method for mixed design. After completion of this class, student voluntarily by its own he has to design a mixed proportion for a particular grade of concrete. Now, so what do you mean by mixed proportion? Why should we select this for proper grade of concrete? Here, the mixed proportion shall be selected to ensure the workability of freshly mixed concrete and concrete. When the concrete is hardened, it shall have required strength, durability and surface finish. What are the objectives of this mixed proportion? The main objective of mixed proportions are like this. It is selected to optimum proportion of various ingredients of a concrete like cement, coarse aggregate, fine aggregate and water in required quantity and will mix it thoroughly. So we have to use it optimally. That means not less than the required or not more than the required. We have to use it. We have to select the ingredients of concretes in optimum proportion. And one more objective of this mixed proportion is to attain the required workability. And the last objective of this mixed proportion is to attain the strength and durability with a minimum cost. Right. Now we'll discuss. These mix proportions are two types: nominal mix and a design mix. Now we'll discuss in nominal mix in detail. So what do you mean by nominal mix? Here in the nominal mix, the proportions of concrete ingredients are adapted nominally. So ingredient means that it is cement, concrete and water will be chosen roughly. I can say roughly, and it is used for only small works, for like routine works like a construction of small residential buildings like this. And what are the grades adapted for this nominal mix are M5, M10, M15 and M20. That means from M5 to M20, not more than that. So this from M5 to M20 we can call it as a nominal grades of a concrete, or the mixed proportion which are used for these grades of concrete called nominal mixes. But this mixed proportions, if I take example of a nominal mixed proportion such as 1:2:3 or 1:3:6, they have no significance for the strength and durability of concrete because we are choosing it roughly. So that because of that choosing roughly or nominally adapted mixed proportions, there may be a chance of variation in the strength at the end of the day. The mixed proportions for the nominal mix as per IS 456-2000 are given like this. As I discussed earlier that the grade of concrete for nominal mix chosen is M5, M7.5, M10, M15, M20. If you take the particular grade of concrete like M5, the required quantity of coarse aggregate for 50 kgs bag of cement, that is 800, and the water required for this is 60 liters. Then what about fine aggregate? Here we have a proportion of fine aggregate to coarse aggregate by its mass. Generally we can adapt the ratio of fine aggregate to coarse aggregate is 1:2. That means if you use one proportion of fine aggregate, then we have to use two proportions of coarse aggregate. Here if I take the example of M5 grade, I have here for one particular bag or 50 kgs of cement a bag, I can use 50 kgs of 800 kgs of coarse aggregate. That means correspondingly, according to this ratio, for preparing M5 grade of concrete, the fine aggregate required is only 400, half of this. That 1:2 represent what? Half of this quantity of coarse aggregate quantity. And similarly for M75, for the one bag of cement, the coarse aggregate required is 625 and the water required by 45 liters. Similarly for remaining thing M10, M15 and M20, are like this. For finally M20 grade concrete, it is 250 kgs of coarse aggregate required for 1 kg bag of cement, and the quantity of water required is 30 liters. And what about fine aggregate? Fine aggregate required for preparation of M20 grade concrete is half of this 250, that is 125 kgs. Here some proportions for nominal mix generally adopted in practice are given in this table like this. For M5, the mix proportions are used is 1:5:10. Then what is the 1 here? It is 1 proportion of cement and 5 proportions of fine aggregate and 10 proportions of coarse aggregate. Similarly for M75, that is 1:4:8, M10 1:3:6, and M15 it is 1:2:4. And finally for M20 grade of concrete, we can use the nominal mix proportion, that is 1:1.5:3. I am again repeating that here 1 means 1 proportion of cement, 1.5 means that is proportion of fine aggregate, 3 means proportion of coarse aggregate here. So this is all about your nominal mix concrete. Then what is a design mix? As I said, the mixes are two types, that is nominal mix and design mix. We have already discussed what is a nominal mix is. Now we will discuss in detail about design mix. In the design mix, the proportions of a concrete are proportions of cement, aggregate, water, and mineral admixtures. If you use any, they are actually designed. So based on the data, we can design what proportion of cement is required for particular grade of concrete, and what amount of quantity required for particular to design the particular grade of concrete, and what amount of water is required for designing particular grade of concrete. That actually those things are actually designed, and it is an accurate one. Because of this accuracy of this design mix, we can use for all important works involving where large quantity of concrete is required. The result of design mix ensures that they will give good workability and they will give required strength and durability. And the whole process of mixed design consists of selecting optimum proportion of ingredients of a concrete like cement, aggregate, water, or mineral admixtures to produce a good grade of concrete with required workability and required strength with a minimum cost. That is the motto of designing the mix. So there are few methods are available for designing the mix. Those are minimum voids method, maximum density method, fineness modulus method, road research laboratory method, that is RRL method, and Americans concrete is ACI committee method, I can say, and finally IS code method. In all these methods, in India we are using IS code method, that is IS 10262 2009. Now we will discuss in detail about this IS code method here. What is the step-by-step procedure for mix design by using IS code method? The first step we have to calculate is a calculation of target strength. What do you mean by, we know a characteristic strength and compressive strength. What do you mean by this target strength? A target strength means if you want to design a mix proportion for for a M20 grade of concrete, you know the characteristic compressive strength of that concrete is 20 Newton per mm square. If you take that particular grade of concrete or particular strength of the concrete and design the mix proportion, you may get wrong proportions, because while mixing the concrete, it involves lot of work with the labors. Because of a poor workmanship, or because of faulty in materials, or because of using inferior quality of material, you may not achieve your desired grade of concrete, that is M20. To overcome those problems, will take some deviation. Because to overcome this deviation, we will target some strength, that is called a target strength. That is, we are assuming more than the M20 grade, right? For this, IS 456 is given. IS 456 2000 is given one formula for calculating target strength of a concrete. That is FT equal to FCK plus 1.65 into S. Here FT is the target strength of the concrete, FCK is the characteristic compressive strength of the concrete in megapascal, or that is in Newton for mm square, and here S is the standard deviation. So the standard deviation values vary with respect to the grade of concrete. Suppose if you are designing for M10 and M15, then while calculating target strength, you can use the standard deviation as 3.5, and if you are designing a grade of concrete M20 and M25, then you can take this S value as 4, and if you are designing the grade of concrete from M30 to M50, then you can use the standard deviation value as 5. Suppose if you take, I am designing here say M20 grade of concrete. For this, how I calculate the target strength here? So FT equal to FCK means here 20 plus 1.65, and S value for M20 grade is 4. So if you multiply that, you calculate that, you will get what is the target strength that will be in MPa generally. Next step will be selection of water content, water cement ratio. This is very crucial step. The water cement ratio depends upon the exposure condition and grade of concrete what you are designing for. So what do you mean by exposure condition? About this exposure condition, I already explained in my last class, that is when you are discussing about property of a concrete. But the water cement ratio can be taken from the table 5 of IS 456 2000 like this. In this table, they have given minimum cement content, maximum water cement ratio, and minimum grade of concrete for different exposure condition with normal weight of aggregate of 20 mm nominal maximum size. This is the title of this table 5. Here, for this step, I want to know what is the water cement ratio for particular grade of concrete as per IS 456 2000. Say here is given for plain cement concrete and has given the for reinforced cement concrete. Generally we are discussing about reinforced cement concrete. Suppose if your intention to design the mixed proportion is for M20 grade concrete, and this M20 grade concrete is laid under a mild exposure condition. It is used under a mild exposure condition. Then what is the minimum water cement ratio, maximum amount of water cement ratio is required? Here for M20, see here, as I am designing for RC's reinforced concrete structure, for minimum grade of concrete is M20. For this particular M20 grade of concrete, what is the maximum water cement ratio we can adapt? That is 0.55. That is W by C ratio is equal to 0.55 we can choose. Similarly, if you take M25 grade concrete, the condition is, suppose the concrete condition is exposure condition is moderate, then we can use, that is 0.50. The W by C ratio is 0.50. We cannot choose the W by C ratio more than this recommended values. We can choose less than that. Right. The next step would be the selection of water content. So how to select the water content? So for this water content value depends upon the nominal size of the aggregate. You know, generally in RCC construction, the maximum nominal size of the aggregate used as a 20 mm, and this value can be obtained from table number 2 of IS 10262 2009. And these codal values are subjected to some slump values. Now, your slump value is represent the workability of concrete. So, if the slump value is between values varies between 25 to 50 mm, then only these codal values are applicable. Say for the nominal size of aggregate is 10, then maximum amount of water content you can use is 208 liters. So these values are subjected to slump. The slump values varies between 25 mm to 50 mm. If my slump value is more than that, then how can I choose my water content? Here code also suggests us that other than the slump values 25 mm to 50 mm, the water content can be increased by 3% for every addition of 25 mm slump. So what do you mean by this? It means, suppose up to 50 mm you have the water content value. Now I want to require what is the water content value for 75 mm slump. Here the code states that for increasing in further for 50 mm to after for increasing further 25 mm slump, you can add 3% of water to that 50 mm slump. Suppose I am taking a 75 mm slump, means up to 50 for I am choosing a nominal maximum size of aggregate as 20 mm. For this 20 mm, if I assume my slump is 50 mm, then it is a 186. But here I am assuming my slump value is 75 mm, means it is 25 mm extra. That means for 186 liters of water, I will add more 3% because the 25% mm slump was increased. So this is how we calculate the water content for designing the mix proportions. Next, the calculation of cement content. It can be calculated from the water cement ratio as we discussed in step number 2. That is W by C ratio is depends upon the grade of concrete and that exposure condition. So from that, the step number 2 we can calculate what is the cement content. And the calculated value or otherwise the calculated value or calculated water content or cement content must fulfill the codal provision, codal requirements. So it is calculated water content is there, it is a cement content. It must fulfill the codal requirement. What code says here, if you want to design a M20 grade of concrete, the minimum grade of concrete you are choosing is M20. For that, the minimum cement required for 1 meter cube of concrete is 300 kgs. So if you calculate the cement content from W by C ratio, that value must be greater than or equal to this value, that is codal value. If less than that, we can redesign again. If greater than that, so it is okay because it is a minimum value. We can use more than, minimum means we can use the cement content more than this also. So this is how we calculate the cement content value by using codal provisions. Next, the proportions of volume of coarse aggregate and fine aggregate. Right. This will be depends upon the size of the coarse aggregate and fine aggregate and zone of fine aggregate. This can be known from table 3 of IS 10262 2009. So this is the table 3 of IS 10262 2009. Right. In this, see, this, as I said, it depends upon the nominal size of the aggregate as well as in which zone our fine aggregate falls. Based on these two criteria, we can calculate the proportions of coarse aggregate, fine aggregate we can calculate. See, if I take, suppose my fine aggregate will falls under zone of 2. For this particular zone, here the volume of coarse aggregate per unit volume of total aggregate for a different zones of fine aggregate. These zones are related to fine aggregate and the volumes which are considered with respect to coarse aggregate and total volume. Here total volume nothing but it is a total volume means volume of fine aggregate plus volume of coarse aggregate. In that we have to take, in that ratio we have to take what is the share or the portion of coarse aggregate in total volume of aggregates. Say for the nominal size of aggregate is, say I am taking 20 mm. For this I am choosing the zone of fine aggregate is 2. So that then the amount of coarse aggregate I will require is 0.62. It is the portion of coarse aggregate in this total volume of aggregates are 0.62. This is how we choose. This is how we choose the coarse aggregate. So if you want to calculate the proportion of a fine aggregate, the total volume is 1. In that you have to deduct this 0.62. Then you will get, that is the proportion of fine aggregate in this is 0.38. So all this we discuss in detail when you are designing a mixed proportion for a particular grade of concrete. Then we can discuss in detail. Right. Next is mix calculation. How to calculate the mix? Here, for calculating the mix, we have to assume that we have to calculate those mixed proportion for 1 cubic meter of concrete. So in that, so 1 cubic meter concrete chosen. From that I can calculate what is the volume of water. You know, the density of anything is mass per volume. From that, if you want to calculate the volume, that will give mass per mass density of that particular material. So here I am calculating volume of water, that equal to mass of water by mass density of water. And similarly I can calculate what is the volume of cement, that equal to mass of cement by mass density of a cement. Here I am giving some equation numbers. So first, for 1 cubic meter of concrete I am giving 1. For volume of water I have given equation number 2. For volume of cement I have given equation number 3. As I know that concrete is of 1 meter cube. In that, equation 2 will give the volume of water. Right. A total volume of a concrete, we have coarse aggregate, fine aggregate, water and cement. Now I want to deduct the total volumes of volume of water and volume of cement from the total volume of a concrete. Say the total volume of concrete is 1. From that 1 I will deduct the volume of water plus volume of cement. Then I will get a mass of all in aggregates. Mass of all in aggregate. That means mass of fine aggregate plus mass of coarse aggregate, that is generally representing here with a small f. So if you want to calculate mass of coarse aggregate, that equal to f means here mass of all in aggregates multiplied by specific gravity of a coarse aggregate and multiplied by volume of that coarse aggregate into 1000. Similarly, if you want to calculate mass of fine aggregates, that will give the formula similar to the coarse aggregate formula, that is equal to f into specific gravity of fine aggregate and volume of fine aggregate multiplied by 1000. So final step, that is a mixed proportion. How to calculate the mixed proportion? Now the mixed proportions are the proportions of coarse aggregates and fine aggregate must be calculated with respect to the cement, as it has a smaller quantity in the concrete. Suppose you want to calculate what is the proportion of a cement, that is mass of cement by mass of cement, that will give the 1. I am choosing with respect to the cement, I want to calculate proportions of remaining ingredients of a concrete like coarse aggregate and fine aggregate. If I want to calculate the proportion of a coarse aggregate, that equal to mass of coarse aggregate by mass of cement. Similarly, if you want to calculate the proportion of a fine aggregate, that equal to mass of fine aggregate by mass of cement. By using all these 7 steps, we can calculate finally what is the mixed proportion required for particular grade of concrete in the sequence of cement, fine aggregate, coarse aggregate. Generally, it is designated as cement is to fine aggregate is to coarse aggregate. In this fashion, we have to give the proportions of a concrete, mixed proportions of a particular grade of concrete. Right. It will be better understand by designing for one particular grade of concrete. To design a mixed proportions for any grade of concrete, so you should know what are the ingredients first. As you know, for any concrete you have ingredients are fine aggregate, coarse aggregate, cement and water. Those all important 4 ingredients of a concrete you have to bring to your lab first. Then you have to conduct some basic test on that, like what is the specific gravity of cement, what is the specific gravity of coarse aggregate, what is the specific gravity of fine aggregate, and what is the water absorption capacity of this fine aggregate and coarse aggregate, and similarly what are the bulk densities of cement, coarse aggregate and fine aggregate, and under what exposure condition you are using this concrete if I prepare the mixed proportion for this, and what is the, if with the different slump values, how my workability will vary. All those things will test in our laboratory first. Right. After a laboratory test, we have chosen that the maximum nominal size of aggregate is 20 mm. The slump required for design of this grade of concrete is 100 mm. As I am designing the M20 grade of concrete, for this particular grade of concrete, I am using nominal size of aggregate is 20 mm, slump is 100 mm, and degree of quality is good. A type of exposure I am using is moderate, and here directly I am assuming water cement ratio is 0.47. So I will check whether this is sufficient or more or less than the codal provisions, then I will check when I will calculating the water content. And cement used for this design of M20 grade of concrete is OPC 53 grade cement. The specific gravity of cement is 3.15. Specific gravity of coarse aggregate is 2.7. Specific gravity of fine aggregate is 2.65. And water absorption capacity of coarse aggregate is 0.5%. Water absorption capacity of fine aggregate is 1%. These are the bulk densities of cement: 1440 kg per cubic meter, coarse aggregate 1650 kg per cubic meter, and fine aggregate it is 1800 kg per meter cube. So with this data, these are the tests which I have conducted before designing of any grade of mixed proportion for any grade of concrete. You have to get this data by conducting some basic test on the ingredients of a concrete. So I have the data is available with me. These are the data which I get. With this data, I want to design M25 grade of concrete. As you know, I have to follow some steps earlier we discussed in our last slides. The first step is calculation of target strength. So my aim is to design the mixed proportion for the M25 grade concrete. For that, the first step is calculation of target strength. I know as per IS 456-2000, for calculating the target strength of that particular grade of concrete, that is, I have formula that Ft equal to FCK plus 1.65 into S. Here, S is nothing but standard deviation. FCK is the characteristic compressive strength of a concrete. Here, I am designing M25 grade concrete. For M25 grade concrete, what is the standard deviation that we can know from table 8 of IS 456-2000? That is, for M25 grade concrete, we can use the standard deviation as 4. By using that, the FCK is 25 plus 1.65 into standard deviation is 4. If you do the calculation, if you simplify these values, then we get 26.6 MPa. So this is the target strength. For this particular target strength, I want to design the mixed proportion. If because of, as I earlier discussed, said that if anything happen, means because of poor workmanship, because of inferior quality of material, if I use during that design of mixed proportion for M25 grade concrete, that will cover here, because we are giving some extra, we are targeting some extra strength than to the compared to the our desired strength. Right. Next one is mixed design calculation for M25 grade concrete. The step 2 is selection of water cement ratio. As I said that the water cement ratio is depends upon the exposure condition and the grade of concrete. This we can take from the table 5 of IS 456-2000. See, already in the data we have assumed that water cement ratio is 0.47. 0.47, make it correct. As per code, for this particular grade of concrete and exposure condition, what is the maximum amount of water cement ratio can be used? So let me check here. I am designing for M25 grade concrete. For M25 grade concrete, the maximum amount of water cement ratio is 0.50 for moderate conditions. For moderate condition, but I am assuming it is 0.47. So my assumption is very much less than our a maximum amount of water content that can be chosen for M25 grade concrete. So hence it is okay. My my approach is okay. Next one is selection of water content. As we know, the selection of water content, it depends upon the nominal size of aggregate. It can be selected from the IS 10262-2009. As in our problem given that the slump required is 100 mm. As I mentioned, but the table, table related to the slump of 25 mm to 50 mm only. Say that for particular size of, for a nominal size of 20 mm, if the slump is 50 mm, then I will get the amount of water is 186 liters. But my slump here is 100 mm. But code has given on provision that for additional increase of every 25 mm slump, then you can add 3% of water. Here for 50 mm, it is 186. For remaining 50 mm, I will divide into two parts, 25 and 25. Each 25 mm of slump, I can increase the water content by 3%, and I have another 25 mm of slump For that also I can increase 3%. Altogether for a the table value, that is nominal maximum size of aggregate 20 mm, for that particular nominal size of aggregate I will get 186 liters of water, but for 100 mm slump, that is 186 plus 6% additional water had to add to this 186. So altogether if I simplify this one, if I calculate this, I will get 197 liters. Right? Now next is calculation of cement content. It can be calculated from water cement ratio already, and water cement ratio I have chosen is 0.47, and from this cement content is equal to W by 0.47, and as already we know W is the water content value already calculated in our last step, that is 197. This is 197 by 0.47 will give me the content of cement, that is C is equal to cement content 419.14 kgs per cubic meter. Okay, well, we have obtained this value. Whether this value is really fulfilling the codal requirements, for that we have to check table number 5 of your IS 456 2000. For this, see here I am using minimum grade. I am designing for the grade of concrete, mixed proportion grade of concrete is M25. For that, minimum cement content required for 1 cubic meter of concrete is 300, but according to my data I got the cement concrete is 419.14 kg for cubic meter. So the obtained value is much greater than your minimum required value, hence my approach is okay, I have calculated correctly. The next one, the proportions of volume of coarse aggregate and fine aggregate. Again this will depends upon size of the nominal size of the aggregate and zone on which fine aggregate falls. Based on these two parameters I can calculate proportions of volume of coarse aggregate and fine aggregate. So I am choosing my fine aggregate will falls in zone 2. From table it clears that for 20 mm nominal size of aggregate, the volume of coarse aggregate per total volume of aggregate is 0.62. Here 20 mm is nominal size and zone falls is the zone of fine aggregate is zone 2. The value corresponding 20 mm and the zone 2 is 0.62. This is volume of coarse aggregate in total volume of aggregates. So from that I can calculate what is the volume of fine aggregate. I know the total volume of aggregates are unity. From that the portion of coarse aggregate will be 0.62. That means I have to deduct 1 minus 0.62. Then I will get the volume of fine aggregate as 0.38. The next step would be mix calculation. See here we have to assume whatever the calculations, what are the mixed proportions we are doing for, that is for 1 meter cube of concrete. So that's why I am assuming the volume of concrete here is 1 meter cube, and in order to calculate the mass of coarse aggregate and fine aggregate, I want to deduct what is from the total concrete volume. I want to deduct what is the volume of water and what is the volume of cement. If I deduct these two things, finally the volume available is only volume of aggregates. Say for calculating the volume of water, that is equal to mass of water by mass density of water. This is the mass of water already we know 197 by, that is 1 into 1000 will be the mass density of the water. I will get 0.197 meter cube of water. Here next, volume of cement. Again volume of cement can be calculated by using the formula mass of cement by mass density of a cement. Here we can calculate mass. We know the mass of cement is 419.14 by 3.15 the specific gravity of a cement multiplied by 1000. We will get what is the volume of cement, that is equal to 0.138 meter cube. Right. Again I have given three different equations. Of equation 1 for volume of concrete, equation 2 for volume of water, and equation 3 for volume of cement. If I want to know what is the mass of aggregate is, then I want to deduct sum of volume of water and volume of cement from the volume of concrete. Here the volume of concrete is related to equation 1, and sum of these two are equation 2 plus 3 will give me the sum of the volumes of water and cement. So according to the above data, here the volume of concrete is 1 minus of sum of the volume of water and volume of cement is 0.197 plus 0.128. Altogether, it will give me the 0.675 meter cube. This value is not only for coarse aggregate, not only for fine aggregate. It is mass of all in aggregate. That is mass of fine aggregate plus coarse aggregate. Now from this, we want to calculate what is the mass of fine aggregate and mass of coarse aggregate separately. For calculating the mass of fine aggregate, we have to use this formula, that is f, small f, nothing but here mass of all in aggregate multiplied by specific gravity of coarse aggregate multiplied by volume of coarse aggregate into 1000. Here the f value is 0.675 and the specific gravity of coarse aggregate is 2.7. It is already given in our problem, and volume of coarse aggregate is 0.62 into 1000 will give me the total mass of coarse aggregate, that is 1129.95 kgs. Similarly, calculate mass of the fine aggregate. Here that equal to same formula same. In place of coarse aggregate values, we have to substitute fine aggregate here. F is 0.675. The specific gravity of fine aggregate is 2.65, and volume of fine aggregate will be 0.38 into 1000. It will give me the total mass of fine aggregate present in 1 cubic meter of concrete, that is 679.725 kgs. This is how we calculate a mass of coarse aggregate and fine aggregate by using this step number 6. The step number 7 and final step will be calculation of mixed proportions. Means what is the proportion of cement, what is the proportion of coarse aggregate, and what is the proportion of fine aggregate that we have to calculate. So as I said that in our step-by-step procedure for mixed design, the proportions of coarse aggregate and fine aggregate must be calculated with respect to the cement, as it has a smaller quantity in the concrete. So based on this concept, we have to calculate the mixed proportions of different ingredients of a concrete. The first one is proportion of cement. We have to calculate the proportion of cement with respect to cement only. That's why mass of cement by mass of cement, that will give me the 1. So next one is proportion of coarse aggregate is equal to mass of coarse aggregate by mass of cement. As you know, why I am using mass of cement is means I am calculating the proportion with respect to the cement. That's why I am taking denominator value as mass of cement. That is, I know the mass of coarse aggregate is 1129.95 and the mass of cement is 419.14, that equal to 2.69, that approximately equal to 2.7. And finally, the proportions of fine aggregate is equal to mass of fine aggregate by mass of cement. I know the mass of fine aggregate I have calculated in my last step, that is 679.75 by 419.14, that equal to 1.62. So there ends the story. So finally what we calculated, the proportion of cement is 1, the proportion of fine aggregate is 1.62, the proportions of coarse aggregate is 2.7. Finally, the mixed proportions are represented in this fashion, that is cement is to fine aggregate is to coarse aggregate is equal to 1 is to 1.62 is to 2.7. So this is how we calculate the mixed proportion for any grade of concrete. So that's all for your design procedures and design design mixed proportion for M25 grade concrete. So based on the today's topic, there are some questions which are asked in your previous completed examinations like ECET, JEE, SSC, JEE. I have taken questions from those previous questions. The first question you asked is, for moderate condition, minimum cement content in kg for M25 grade concrete as per IS 446-2000 is. So to answer this question, you should know codal provisions. and according to the table number 5 of IS 456 2000, so the given grade of concrete is M25 and the condition of exposure is moderate. By considering these two parameters, what is the minimum amount of cement required to design M25 grade concrete is? Here now coming to table, for minimum grade of concrete is M25 and the exposure condition is moderate. By considering these two, as it is considered as RCC, the minimum grade of concrete, minimum amount of cement required for this particular case is 300 from this IS 456 2000. See this value 300. So the answer D is correct. So dear students, for preparing, when we are preparing competitive examination, you should remember codal values definitely, especially with the subject like reinforced concrete structures and steel structures. Right. The second question asked is, calculate the target strength in MPa for a M25 grade concrete as per IS 456 2000. So for according to the IS 456 2000, we know the formula for calculating target strength, that is FT is equal to FCK plus 1.65 into S. Here FCK is characteristic compressive strength of a concrete and S is the standard deviation. This is depend upon the grade of concrete. As FCK is 25 plus 1.65 into standard deviation for M25 grade concrete is 4. So if I calculate that, I will get 26.6 MPa. So according to this question, option B is correct. So that's all for today's lecture. Thank you.